This paper is basically looking at what are the drivers of national food supplies. We use a cross-country analysis to look at this paper. So dietary diversity has been acknowledged as significant for adequate nutrient intake, and it's been considered as a strong predictor of growth in young children. But what drives dietary diversification over the course of development? So microeconomic studies show strong income elasticities for most nutrient-rich foods such as meat and dairy. And but farm household models point to several market failures, that diets are influenced by local production patterns such as agroecology because markets don't supply full range of desired foods. Microeconomics theories of imperfect markets also suggest that the speed of diversification vary very substantially even between countries at similar income levels. And dietary diversification has been slow in some countries. However, little previous research actually analyzes DFS, even though DFS is a necessary condition for diversification of individual diets. So in this paper, we address 3 questions: how DFS varies across countries and regions, how rapidly has DFS changed over time, and what structural transformation and agroecological indicators may be driving these trends in DFS. So we use a cross-country panel data set that merges data from a variety of sources. The food balance sheets from the FAO have been used to create a very simple DFS indicator, which is our outcome variable, share of calories supplied from non-staples. We use consumption, expenditure per capita, share of urban population, share of children aged 0 to 14 years, measures of topography that might influence production diversity, and infrastructure indicators in this data set. So for that, we include road density, international shipping costs, and electric power consumption to the sample. And after integrating all these data sets, we have a 5-year unbalanced panel data set of 51 countries for the period 1965 to 2010. And in terms of analysis, we use descriptive techniques, panel regressions, and decomposition analysis to understand drivers of DFS change over time. Okay, so given that we have panel data, we first estimate fixed effects models of the form to assess the associations between diversity of food supply for a country I and time t, and a vector of time-varying intermediate determinants such as consumption, education, urbanization, and population ages 0 to 14 years. But we're also interested in time-invariant factors such as agroecological indicators. So therefore, we use the correlated random effects model in order to keep these vector of time invariant variables. And the resulting estimates can be explained in line with the parameters from a fixed effects model. So this presents a map of DFS across countries for the year 2010 with darker shades of blue representing greater DFS. And the map indicates that North America, Western Europe, Australia, New Zealand, and several Latin American countries show the highest levels of DFS. In contrast, South Asian countries have low DFS, particularly Bangladesh and Nepal. And in Africa, DFS is very low in West Africa, Ethiopia, and much of Southern Africa. So this figure plots DFS against consumption per capita for the year 2010, with the lowest line showing the predicted relationship. And we can see that consumption per capita is strongly associated with DFS, although there is substantial variation around the predicted relationship. For instance, we can notice some large negative outliers are often rice-based producers, such as Bangladesh, Madagascar, Laos, Indonesia, and Cambodia, Egypt. This reports trends in DFS for income groups, major regions, and countries over the period 1965 to 2010. And we can see that dietary diversification was slow in the poorest income groups in contrast to upper middle income and high income groups. In sub-Saharan Africa, there's been very little change in diversification in food supplies, just 5 points on average. In South Asia, changes in India and Bangladesh were very modest, just 3 and 4 points. In East Asia and the Pacific, China experienced dramatic increases in DFS, but in Indonesia, only saw a modest 6-point increase. So this plots DFS trajectories against changes in consumption per capita. We're focusing on selected Asian countries. So China is an example of extremely rapid diversification of food supplies, followed by Thailand. Indonesia food basket appeared to have diversified slowly. In the case of India, the DFS picked up during the 1990s and 2000s during a period of prolonged economic growth. And Bangladesh has experienced solid growth in consumption since the mid-1990s. and its food supply has begun to diversify from an extremely low base. So again, in this case of African countries, Egypt follows a flat trajectory with scarcely any DFS over the course of rapidly economic growth. Ethiopia has even lower levels of consumption, but recent economic growth appears to be translating into a more diverse food supply. Ghana follows a similar pattern, and Madagascar is an example of a country where per capita consumption has actually fallen over time. So in terms of results, we find that growth in consumption seems to be a strong predictor of DFS, but there is substantial heterogeneity. And this heterogeneity may exist because of market failures that's limiting the ability of national food supplies to diversify food supplies. And that may also be the result of demand-side factors. So here we have a table reporting fixed effects and correlated and random effects model of this semi-log DFS model. So we find that consumption per capita, urbanization, and population ages 0 to 14 are strongly associated with DFS in both these models. We also find that road density matters for DFS. And we also find that population density has the strongest marginal effects. And we also see that too much rainfall and too much water actually tends to constrain diversification. So we now use these regression results to analyze the predicted sources of DFS change over time using a simple decomposition at means technique. And among the sources of predicted sources of change, consumption per capita stands out, the single largest factor, explaining 41% of the predicted DFS change over time. So while economic growth is the strongest, largest factor, urbanization and demographic changes are also very important. And overall, it appears that all these three structural transformation indicators do a good job of predicting changes in DFS over time. So in conclusion, this is the first cross-country study explaining DFS with panel regressions. We find strong support for Bennett's law that economic growth matters, but we also find evidence that there are other structural transformation indicators that explain DFS, which are urbanization and demographic changes. We find that road density explains DFS. Also, high population density, high rainfall, high groundwater predict lower diversity that may be related to rice production. And we find evidence that many countries that are major producers and consumers of rice seem to have undiversified food supplies. And one explanation may be that these countries share certain agroecological characteristics that give them a comparative advantage in rice production and a comparative disadvantage in production of nutrient-rich foods. So in terms of policy implications, yes, economic growth and broader structural transformation indicators are major drivers of diversification, but our results provide a strong role for food policies as well, that diversification can be slow and hindered by production constraints. So therefore, it is critically important for food policies to focus on reducing the real price of nutrient-rich foods via production and trade interventions. So dairy is a particular example. Dairy consumption in Bangladesh is usually very low, and domestic potential is very limited. Thank you.